Hello students and welcome all of you. I hope all of you are doing great. In this particular problem we have been asked that for a non-negative integer n, let f of n is equal to this particular expression over here. So again, furthermore, assuming cos inverse of x takes value in 0 to pi, which of the following options is are correct? So basically we have to use this expression f of n to figure out which of these options are correct. And how will we do that? There is a summation sign over here in numerator and denominator, and there are trigonometric functions. So it's quite understandable that we will use trigonometric formulas and properties to figure out a simplified version of f of n. How do we do that? Let's just check out the numerator first. In the numerator we have sine of one angle multiplied by sine of other angle. There is a formula called 2 sine A sine B, right? We can apply that and simplify it further down. Let's just see. For that we will need 2 in the multiple in the numerator. So what do we need? I'm gonna write it down as 1 by 2 so that we divide with 2 as well. So we have 2 of sine of same angle. I'm not gonna write the angle over here. It is the same thing in numerator, that is k plus 1 divided by n plus 2 pi, and k plus 2 divided by n plus 2 pi over here and over here. Same thing. Okay. In the denominator as well, I'm gonna apply one formula known as 2 sine square theta, that is 1 minus cos 2 theta. Okay, so it's gonna become like the same thing, 2 sine square, the same thing, the same angle. I'm not gonna change the angle, it's gonna same thing. Okay, now furthermore, as you can see, I can cancel down 1 by 2 1 by 2 over here. Now what do we have over there? Summation k is equal to 0 to n. Now I will apply my formula. If I take the second one as a and the first one is b, then according to the formula 2 sin a sin b, that is cos of a minus b minus cos of a plus b. So k plus 2 minus k plus 1, that is k plus 2 minus k minus 1, that is only 1 remains. So I'll have cos of 1 divided by n plus 2 pi over here minus cos of now k plus 2 plus k plus 1, that is 2k plus 3 divided by n plus 2 pi over here. So this is how it's gonna become divided by k is equal to 0 to n. Now it's gonna convert into 1 minus cos 2 theta. So 2 times what is it? 2k plus 2 divided by n plus 2 pi, like this. Now we have this particular version with us. As you can see, in the first term of the numerator there is no k term at all. So if there is no k term at all, you're gonna add this term how many times? There are n plus 1 terms, right? So n plus 1 times you're gonna add it. So I'm gonna just multiply n plus 1 with cos of, I can simply write it as pi divided by n plus 2 minus, and this particular term will require a little bit of work, we'll get to that. Let's just see, let's just write it down as it is for now. We'll just work on it. Okay, now divided by, what do we have? Summation of k is equal to 0 to n 1. So as you can see, 1, how many times we are adding it? We are adding it n plus 1 times, and let me just write n plus 1 over here minus again over here. What do we have? We will need some work. Let's just see, I'm gonna write it like this for now. K is equal to 0 to n cosine of 2k plus 2 divided by n plus 2 pi. Now we have simplified till here. Okay, over here now we don't have any other option, so it's better to open the summation sign. How to do that? We will plug the value of k and figure out how it is looking like. So I'm gonna write it again, n plus 1 cosine of pi divided by n plus 2 minus, now if I plug the value k is equal to 0 over here, it's going to become 3 pi, right? So cosine of 3 pi divided by n plus 2, like this, plus cosine of, now k is equal to 1, if I put, it's going to become 5, so 5 pi divided by n plus 2. In the same way, it's going to become cosine of 7 pi and all. It's going to proceed exactly like the way how it is proceeding now. 7 pi, then 9 pi and all. Okay, now the final term is going to be 2n plus 3 divided by n plus 2 pi over here. Fine. Okay, this is going to become the final term. Okay, divided by, I have already n plus 1 over here, writing it as it is. Now opening this thing up, k is equal to 0, so it is going to become cosine of 2 pi divided by n plus 2 plus cosine of 4 pi divided by n plus 2 plus dot 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 cosine of 2n plus 2 divided by n plus 2 pi over here. Okay, so this is how it's gonna become. Okay, proceeding ahead, now we have something. Now I'm gonna write something over here so that you understand that whenever we have something like this, there's a cosine and the angles are in your AP. The common difference you can say is 2 pi divided by n plus 2 in the numerator and in the denominator as well. So in that particular case, whenever the common difference, suppose it is d for first term a for n terms, okay. In this particular case, the solution of this is given by, if the cosine of the angles are in AP, it's given by sine of nd by 2 whole divided by sine of d by 2 cos of first term plus last term by 2, or simply you can write 2a plus n minus 1 d whole divided by 2. That is first term plus last term divided by 2. Okay, now how I can write it in this for this particular equation. So let's just proceed ahead. First expression will not change, n plus 2 will remain as it is. Now this is gonna become what? Let's just see. So sine of, how many terms are there? There are n plus 1 terms, so n plus 1 multiplied by d by 2, difference is your 2 pi divided by n plus 2 by 2, right? This whole thing, right? Whole divided by sine of d by 2, that is again your d is your common difference, 2 pi divided by n plus 2 by 2 multiplied by cosine of first term is 3 pi, last term is 2n pi plus 3 pi. So basically 2n pi plus 6 pi. If I take 2 common, it will become, n plus 3 pi. Okay, so okay, let's just write it like this. 3 pi plus 2n plus 3 pi whole divided by first term plus last term divided by 2. If I solve it further, if I solve it further, it's gonna become a more easier version. Let's do that as well. So n plus 1 over here in the denominator minus, I'm gonna do the same thing what I did in the numerator. I'm gonna apply this particular formula. It's gonna become sine of, again n plus 1 terms are there, so n plus 1 common difference is again 2 pi divided by n plus 2 multiplied by 2 whole divided by sine of 2 pi divided by n plus 2 multiplied by 2, again cos of, let's just say first term is 2 pi, last term is 2n pi plus 2 pi. If I add, it will become 2n pi plus 4 pi. So I can write, if I take 2 common, it is going to become n pi plus 2 whole 2 pi, sorry, 2 pi divided by n plus 2, okay, multiplied by 2. Again 2 cancel, here also 2 cancel, here also 2 cancel, 2 cancel over here, 2 and 2 cancel over here. If I just simplify this particular thing over here, so what I can do is, let's just simplify it over here. Okay, so I'll just write it as, yeah, so I will have n plus 3 divided by n plus 2 pi with me. Yeah, that is more simplified version. Now proceeding ahead, we have n plus 1 multiplied by the same thing, cosine of pi divided by n plus 2 minus. Now just check out what is given over here, n plus 1 pi divided by n plus 2, and over here pi divided by n plus 2. If you see, I'm just gonna write over here n plus 1 pi divided by n plus 2 plus, why I have added, I'll just let you know. In both, if I take pi common, it's going to become n plus 2 divided by n plus 2, cancel, it's going to become pi. So if at all we have two angles whose sum is 180 degrees or pi, those two angles are supplementary. Supplementary means if one is theta, the other is pi minus theta, right? If that is the case, I can simply cancel these two down, right? I can cancel down this, and this. So if these things are cancelled, then what I can do is I can simply remove them. And also, if you can just check out that if I take pi common, if I just take pi common over here, so it is going to become, let me just remove the pi from here and write pi over here. So n plus 2 cancel, right? So cos of pi will give me -1, already cancelled. So -1 and negative. In the denominator I'll have n plus 1 plus 1, that is n plus 2. Fine. What will happen in the numerator? Let's just figure out. We have n plus 3 divided by n plus 2 by pi. So better, let's just figure out how to write it properly. I'm going to write it as cos of n plus 2 plus 1. Okay, let's just break it down, n plus 2 pi like this. Okay, this whole thing is inside the angle. Okay, now this is your cosine numerator. Now in the denominator we have n plus 1 plus 1. As I told, that we have cos of pi, that is -1, negative of -1 is +1, or let's just simply write it down as n plus 2 in a more better way. Yeah, now let's see what do we have. So we have n plus 1 cosine of pi divided by n plus 2. Now what is this particular thing? This is cosine of this value, again cancelled. This is your pi plus pi by n plus 2, right? So cosine of 180 degree plus theta is nothing but minus cos theta, right? So if that is the case, minus of minus again become plus. So I can write cosine of pi n plus 2. Now I can take from the numerator n plus cosine of pi by n plus 2 common. Again it's going to become n plus 2 whole divided by n plus 2. This cancel. So ultimately my f of n value is equal to cosine of pi divided by n plus 2. Now we have a simplified version of what we wanted. Now let's just see what have been asked. So alpha over here in option number A, alpha is equal to 10 of cosine inverse f of 6. So in option number A, alpha is equal to 10 of cosine inverse f of 6. Cosine inverse. So what is f of 6? Basically f of 6 over here is cosine of pi divided by 8, right? So whenever we have this kind of condition, they kill each other, right? So in that case I have been left with 10 of pi by 8. If you remember the value of pi by 8, 10 pi by 8 is square root of 2 minus 1. So this is basically our alpha, what we have been asked. Okay, then we have to check that alpha square plus 2 alpha minus 1 is equal to 0 or not. So taking 1 over that side, it's gonna become alpha plus 1 is equal to square root of 2, squaring both sides. So alpha square plus 2 alpha plus 1 is equal to 2. That is basically alpha square plus 2 alpha minus 1 equal to 0. So our first option is absolutely Correct. The second option, let's just check. In the second option, we have f of 4 equal to square of 3 by 2. So for the second option, f of 4 is equal to cosine of pi divided by 6. So cosine pi by 6 is square root of 2. We already know that, right? Pi by 6 is how much? Like 30 degrees. Cos 30 is square root of 3 by 2. So this is absolutely correct. Okay. For option number C, it is given that sine of 7 cos inverse f of 5 equal to 0. Sine of 7 cos inverse f of 5 equal to 0. Let's just see what is it. Sine of 7 cos inverse cos of pi by n plus 2 is 7. So again this thing will kill each other. It's gonna become sine of 7 pi by 7 or sine of pi, that is sine 180 degree, is equal to 0. This is also absolutely correct. It seems all the options are correct. So we have last one, limit of f of n where n tends to infinity equal to 1 to 2. Let's just check. So in D part we have limit of f of n where n tends to infinity equal to 1 by 2. So for here we have limit of n tends to infinity cos of pi divided by n plus 2. Now if I put infinity over here, the whole expression is going to become cos of 0, and cos of 0 is your 1, which is not equal to 1 by 2. So this particular option is not correct. So finally your correct option will be A, B and C. Thank you so much everyone. I hope you have understood this particular problem, how to solve it. Thank you so much.